Welcome to the Climate Smart and Climate Ready Conference. I want to welcome back those of you who joined us already at our Thursday and Friday events, and welcome to those of you who are joining us for the first time this morning. I'm Gay Nicholson. I'm the president of Sustainable Tompkins, and we have served as the coordinator and host for the conference. I want to start by thanking all of you for being willing to be involved in this work of protecting and preparing our communities as climate change starts to hit home here in our region. As many of you may know, last fall our Assemblywoman, Barbara Lifton, pulled together a coalition of people from business, from higher education, the nonprofit sector, youth groups, and local government from both Cortland and Tompkins counties into a conversation about working together to respond to the threat of climate change in our communities. And although, of course, there's already been a lot going on for many years in the energy and climate arena, we agreed that coming together in a conference for our counties could be very useful and hopefully would attract new people into this very vital conversation that has been ongoing but really needs to expand now. So we've got a great series of presentations to share with you today, but first I wanted to acknowledge once again our gratitude to the conference sponsors. We ended up with a grand total of 31 sponsors for this conference, for this 4-day extravaganza on climate, led by Park Foundation, and also 2 locally owned insurance companies, the McNeil and Company Insurance out of Cortland and Dryden Mutual Insurance. They were very quick to respond to our vision for the conference. As you might imagine, the insurance industry understands risk when they see it, and that's one of the reasons why you have the whole industry, insurance industry has been involved in climate issues for quite some time, for decades really. We also want to recognize the significant support from Holt Architects and the Atkinson Center for a Sustainable Future at Cornell, along with Adelaide Park Gomer and Assemblywoman Lifton. And then, of course, there are a whole array of other local businesses, local governments, universities and colleges, and other nonprofits who have become financial sponsors. And if you'll take a moment to look at the big poster out in the lobby, you'll just see how the generous people who have helped make this happen. But we owe, I think, an equal debt of gratitude to the people who've been involved. And there's been 20 or so people on the planning committee working over many months since last fall, as well as maybe another 20 or so volunteers who've stepped forward to help manage and put on the conference over the 4 days in all these different locations. So I just want to give a moment to, if you're involved, please stand so we can acknowledge your contributions to the thank you, everyone. That's a great little group of climateers there. It's just been a pleasure to work with so many talented and generous people putting this together. So after this morning's plenary, please join us for a coffee break and networking out in the lobby before selecting which of the 12 concurrent sessions you're going to go to for the afternoon, the rest of the morning and the afternoon. There are, as you can see in your program, tracks for community, business, and local government. And lunch is on your own downtown. There's a little insert about downtown with restaurants in case you're not familiar with and already have one picked out. But we hope you'll be very prompt in coming back and getting into all of your sessions on time. They're only 1 hour long, and we have packed them full of interesting information that you won't want to miss out on. We have over 75 speakers involved in the conference over the 4 days, so let's honor their contributions and be timely in going and listening to them. Then after 4:30, we're going to finish up the day over in Center Ithaca in the big atrium over there for a closing plenary where you can enjoy a glass of local Sheldrake Point wine that's been donated, as well as local handmade dark chocolates by Luciennes that have been donated, and really tasty array of treats from Dancing Turtle and Macro Mamas. So we'll make sure you eat healthy too. Healthy and local. And so while you're enjoying that, you can sit together at topic tables, and that's where we would like to reflect upon the day's learnings and any surprises and what you think we can be doing next, so that we come out of today's work together with a sense of direction and possibility, so that we don't just stop here. Obviously, this is just another stage in the evolution of our work together. And then Mark Hertsgaard will be with us then to help us summarize our day together. So again, thank you for joining us in this work of making our communities climate friendly and climate resilient. I'm just really pleased to see all of you here. And with that, I'm going to turn things over to our Assemblywoman, Barbara Lifton. Barbara.
Good morning. Good morning. Thank you, Gay, very much for your introduction there, and thank you, all of you, for being here today. I don't know how many of you, I suspect a lot of you were at the hangar the other night to listen to our wonderful keynoter here, Mark Hertsgaard. And the other night at the hangar, I said that this Climate Smart, Climate Ready conference came out of my concern over about a year ago, thinking about this, that the federal government and the state government as well are not fully rising to the challenge of global warming. And my having run across Mark's book, Hot, and being inspired by that book and to getting people together. And that's certainly true. But the deeper truth on this conference is more akin to Thomas Edison's famous line about 1% inspiration and 99% perspiration. And so my little momentary burst of inspiration fell on very fertile ground here in my assembly district. The great work, as Gay said, that's been going on here for many years throughout so much, really every part of this community, most obviously by the amazing and wonderful Gay Nicholson at Sustainable Tompkins. And let's all thank Gay again. You know, I'd heard a lot about Gay over the years and certainly knew her, but I'd never worked closely with her before. And I've worked very closely with her on this and just been endlessly impressed by her great intelligence, her caring, her unbelievable hard work, and her, believe it or not, with these combinations of qualities, endless patience. I never saw her once through all of this enormous planning and preparation, dealing with so many things and so many people. Lose it, and I'm sure my staff here, and I want to thank my staff, knows that I lose it occasionally. And that's really a very, very important quality for helping people to work together as effectively as this group has, and all stay on good terms through many decisions to be made. And progressives aren't always famous for doing that. So it's really a wonderful model that Gay is key in sustaining here. And also I want to note the wonderful supporter for Sustainable Tompkins over the years, Adelaide Park Gomer. Also, the other great groups that have been working on this, Cooperative Extension, many business people locally, Cornell, Ithaca College, Sustainable Cortland, Beth Klein is here, and other people from Cortland. And the leadership shown by our cities and our county, especially Tompkins County, on this issue. Thank you for all those leaders. Tim Joseph, is Tim in this meeting? Tim's here. Tim, I was saying, you were part of getting those solar panels up on the library, I don't know how many years ago, but a long leadership on this issue. And so when I called upon all these key stakeholders in our community, the Chamber of Commerce even, and all of these other groups, and said, hey, why don't we all get together and put on a play? My early background was theater, so shall we all get together and put on a play? They were more than ready to say yes. Let's get together and collaborate on this, on doing something together. And what do we want to do? We spent a lot of time brainstorming and figuring out what would be good. And so I want to thank everyone, all the key stakeholders in this collaborative effort. And it's only through this kind of collaboration that we are going to tackle this tremendous challenge. And we are creating a model here for what that collaboration ought to look like. And I think it's been a very successful model over these days. I've already heard so much good feedback about the work people have done, the ag workshop over in Cortland yesterday. So I think we are creating an important model here for how work can get done around the country when, again, when the larger levels of government, state and federal, clearly are not doing enough at this point. I want to thank Mark Hertsgaard very much. When I read his book and was so impressed by it, I emailed Mark and asked him if I emailed him, he's out in San Francisco in California, I asked him if he'd come and speak to us here, and he immediately responded, maybe with some trepidation, Mark, we'll see if they pull this together. But he said yes, and he's been very important, I think, to the success of this conference. Thank you, Mark, very much for all the work you've done with us over these many months, helping to pull this together. And so again, I want to thank everyone, and we'll move on to the next piece of this plenary session. Thank you. Oh, Frank. And yes, I'm introducing Frank DiSalvo from the Atkinson Center, who's now going to help lead us in the next piece of this. Thank you, Frank.
Thank you, Barbara, and thank you all for coming this morning. It's nice and crisp out there, so I assume everybody's awake and ready to go. The Atkinson Center convenes research talents and capabilities at Cornell and connects them with outside organizations to try to find solutions to vexing problems in sustainability. Over 300 faculty in 65 departments are currently engaged with the center, including the 4 panelists in this morning's session. My job is just to introduce the panel moderator and the panelists. Mark Hertsgaard is the panel moderator. Even though many of you know something about Mark, I'll repeat a few small things, and that is that Mark, as you know, is a leading environmental journalist. He's the author of Hot, we've heard this morning, Living Through the Next 50 Years on Earth is the subtitle, and 5 previous books that have been translated into 16 languages. He's a fellow of the New American Foundation, the environmental correspondent for The Nation, and a co-founder of the group Climate Parents. Mark's latest book is most notable for his eyewitness reporting on existing solutions for avoiding the unmanageable and managing the unavoidable of climate change. So he will be the moderator. I'm going to introduce the 4 speakers, the panelists this morning, in the order in which they will get up and make a presentation. So it's going to start with Art DeGaetano. He's a professor of Earth and Atmospheric Science at Cornell. He's also the director of the NOAA Northeast Regional Climate Center. His research focuses on observed climate change and the application of climate information to decision making. He was a principal investigator on the 2011 New York State ClimAid report and has been involved in the 2013 National Climate Assessment. He and his group of colleagues were recently awarded a grant to develop a website that will serve as the New York State Climate Change Clearinghouse. Next will be David Wolfe, who is a professor of plant and soil ecology in the Department of Horticulture at Cornell and chair of the Atkinson Center's Climate Change Focus Group. He has been involved in climate change research for over 20 years and has been involved in numerous regional and national assessments, including lead author of both the ecosystems and the agricultural chapters of the 2011 New York State Climate Aid report, and one of the most comprehensive state reports on climate change in the nation. Shorna Allred is an associate professor and associate director of the Human Dimensions Research Unit in the Department of Natural Resources at Cornell University. Her research and extension program focuses on understanding attitudes, motivations, and behavior related to resource conservation and management and policy alternatives. She has conducted research and outreach to provide sound guidance to municipal officials, land managers, landowners, and professional agency staff on how to respond to anticipated climate change so that natural resources will be resilient and New York's communities will be more sustainable. She has researched the views of local climate change mitigation and adaptation barriers and the information needs of natural resource professionals and local government officials in New York State. The last person to speak and to be on the panel is David Kay. He's a senior extension associate at Cornell's Community and Regional Development Institute, or CARDI, in the Department of Development Sociology. A trained economist, David focuses on CARDI's interdisciplinary research and outreach efforts concerned with land use, local government, community energy transitions, and community economic analysis. Over the past 30 years, David has been involved in many organizations at the state and local level devoted to community planning and sustainability issues. And so that's the group this morning, and without further ado, I'll ask Art to start it off. There you go, Art.
Good morning, everybody. If anyone has seen me speak before, you know I have a hard time standing behind a podium when I speak, but I'll give it the best shot here with the microphone. I think actually in some cases, a good way to summarize my talk is we have a perception problem. And I'm gonna say we have a perception problem because I handle a lot of calls from people, farmers, the local community, reporters, and basically the calls I've been getting lately is how come this spring has been so cold? How come the growing season is so far behind? When you look at the data, this is what it should be like. So I'll leave it at that. I'm going to start off with a global view. I think this is probably something that most people have seen already. This is the global average temperature record going back to the late 1800s. And I think you can see the dramatic trend, particularly since the 1970s across the globe in terms of annual mean temperature. If we're looking at degrees Fahrenheit, we're probably looking at about maybe a half to a full degrees. I'm sorry, these are half to a full degree Fahrenheit of change globally over the last 30 years. And this is remarkable from a historical perspective, or actually even a geological perspective on Earth. So even though a degree doesn't seem like that big of a number, it clearly is. If we look at the warming in the recent record, we can see the entire globe has essentially warmed, except for a few outliers, mainly the darkness of the red indicates the degree of warming, again in degrees Fahrenheit for this purpose, with most of the warming in the Arctic. Again, this idea of feedbacks in the climate system. As we warm the climate, we melt the ice, we melt the sea ice, which has gotten a lot of press lately, and that only adds to the warming in these Arctic regions. And of course, in the winter and things like that, that's where our weather comes from, so we're affected by that. If I do focus it down a little bit closer to home, this is the northeastern United States, kind of the states here that I have outlined in my little logo here. And we can see through this period of record, again, from the late 1800s to the present, early in the record, we're probably talking about an average temperature for this region of about 46 degrees Fahrenheit. And we can see in the more recent period of record, we're up to about, I can't see my slides from here, probably something about 48 degrees Fahrenheit. So again, this idea of about a 1 degree, maybe even more if we look at the Northeast warming over the last 30 or so years. If we look at this seasonally, we see the temperature change mainly has occurred in wintertime. Winter, spring, summer, fall. We can see at least the statistics here of the amount of change. These are fractional degrees, about 1/10 a degree per decade. Clearly, by far, the warming is pronounced in the winter. Kind of goes back to that previous slide where we see a lot of action going on in the Arctic in the winter. So these things kind of make sense and go together. Again, these numbers are kind of hard to make sense. What does that mean to me or you or Tompkins County or Cortland County? So maybe to go a little bit further, what I'd like to do is really pull on some data that we have that we put together for both the New York State Climate Report, okay, to kind of bring this idea of global climate change down to the state level, look at factors in climate change other than the averages that matter to people, matter to farmers, matter to local governments, matter to businesses, matter to the insurance industry. And then also, I'm going to pepper this also with some results from the soon-to-be-released 2013 National Climate Assessment. And if you're familiar with those assessments that the federal government has done in the past, they do kind of break them down into regional levels. So we were highly involved in what was going on in the Northeast. So here, if we look at a summer record here, these are days above 90 in a smattering of cities across the Northeast, and even in Canada in this case. And I think in each of these, we see a fairly good trend, Boston in particular, even New York City, in many more days above 90 degrees in our summertime. So again, if we're looking at local communities, I think this was something that I at least heard in the hallways this morning. Things, warming centers in the winter versus cooling centers in the summertime. That might be something that we need to think about in our cities. Particularly cities, if we look at places like Montreal or even New York and Boston that aren't quite used to that. Probably a good system in place in places like Washington. Days with snow on the ground, again, a winter example. Again, some clear trends toward less snow on the ground, but there are some oddballs out here. I say, why has it snowed so much lately? And again, these are, I think my good example, I should have put it in here, a nice slide that I like to say is, I think it's gotten out on a lot in the public media or in, basically it's a picture of a guy walking a dog along a sloping line, and the dog is just going all over the place with his leash. And, the idea here is that jogs like this occur. They're part of the natural weather system. They're superimposed upon climate change. There are reasons to expect in a warming world, even in winter, that we might get more snowfall. A lot of cases this winter where we saw that, if a lot more moisture in the atmosphere when it snows, particularly in the wintertime. So having these big events is not inconsistent with climate change. If we look at precipitation, on the other hand, this is, again, the global perspective. We see somewhat of an increasing trend in average precipitation. We'll go into the numbers. If we look at the Northeast, maybe an increase here in the more recent period of time. But if we look at the numbers, not all that huge of a change, something less than a 5% change in annual precipitation. But again, getting to what matters is not necessarily the averages, but the extremes. And just like that snowfall example, we see that very, very, very clearly with rainfall. So actually, this is where a lot of my research has been focusing lately. If we look at the Northeast, it kind of sticks out as an anomaly on the high side, where what this shows is the trend or the change in very heavy precipitation events over roughly the last 60 years. And in this study, very heavy is described as 2 inches of rainfall in a 48-hour period, so 2 inches in 2 days. And basically here we see almost a doubling, a 75% increase in these rainfall events. And I think here in upstate New York, we don't have to look too far to see the impacts of rainfall events such as that. This is a trend that is more than just New York, any number of cities across the Northeast. I guess I stole this slide from a talk I gave in New England, so sorry about the lack of New York stations, but still, same type of thing. We see this across Connecticut, across New England, across New York, across Pennsylvania. The other problem, again, maybe not so much for Tompkins and Cortland County, but I think looking at a New York perspective, really sea level rise is the impact that's going to be most important in our region. And this is observed sea level rise at a number of cities across the eastern coast of the U.S. And we can see, again, I don't have my numbers in front of me here, on the order of over this past 100 years here, significant sea level rise. And this sea level rise is projected to be even greater over the coming 50 or 100 years as the oceans continue to warm, as places like Greenland and Antarctica continue to melt, where we could be looking at sea level rises on the order of 1 to 2 feet for many of these cities. And I often get questioned about Hurricane Sandy and its relationship to climate change. And the response that I want to give, as a meteorologist, I don't think climate change had much to do with that particular storm, but I think that particular storm is very much a sentinel to the types of impacts we can expect to see under climate change from more ordinary storms. With the rising sea level and surges like we saw with Sandy superimposed on that, those types of impacts in our East Coast cities will become more widespread. All right, so what does the future hold, basically? So going into the future, and it hold a lot of things. I like to ski, so I hope that's not my future. Basically, the way we do this is we have to ask a climate model. We have to look at representations of the climate system and see what they show in the future. We don't have enough data to make firm estimates of how climate can change. We're basically working in uncharted ground, so we have to use our best ability to model the climate system mathematically, scientifically to see that. And basically what I have here, numbers don't really matter, but on the top I have climate model projections for the next 80 years for temperature. Each of the different colors represents a different climate model. And for temperature, I'd like to say that all of these go up with pretty much the same rate. There's some spread in these models at the end, but they generally generally paint the same picture. There's some nuances on the degree of change, but generally they're all showing a degree of warming. If we look at precipitation, the picture is slightly different. The lines are a lot messier. They show a lot more spread. There's one model here in the light blue that actually shows maybe precipitation to decrease. Okay, so our certainty about the risks of things related to precipitation is less than our certainty in terms of things related to temperature, but that doesn't mean we shouldn't act on these, right? We have to factor in that uncertainty into our decisions. Really a lot, or a part of this uncertainty is actually what do we do, right? If greenhouse gases are driving this, we have to know into the future whether we end up emitting almost 3 or 4 times the amount of carbon dioxide and greenhouse gases that we do today. That has a different outcome in the climate picture, versus maybe if we do something a little bit more sustainable, and this is CO2 emissions, and notice the green line here, you know, by 2100, we're doing what we're doing today. This point here and this point here today are generally the same spot. But even here, we see big differences in the outcome of the climate system. So even though I like to work with climate data and climate models, I think one of the biggest unknowns is this. How do we end up with our greenhouse gas emissions? Unfortunately, our track is maybe worse than what we see up here. So that's something that has to play out, and hopefully something that will at least start to come out of conferences like this. Like I said, a lot of the data I'm pulling for the future is coming out of these 2 reports, basically the ClimAid reports that Frank mentioned, basically a synthesis report, a quite readable, 30 or 40 page document, or the granddaddy here, I think it's about 600 or so pages, Dave, document. So if you're having problems sleeping, that might be the one to read. And then also this draft climate change assessment that's coming out in this coming year from the federal government. This is from our ClimAid work. It's basically showing projected climate change across the state of New York based on a number of different climate models. So basically averaging together a lot of those colored lines I showed you in the previous slide. And basically we see by the end of the century, by the 2080s, we're looking at temperatures across the state that are on the order of 6 to 7 degrees Fahrenheit warmer than they are today annually. That's a big difference. If we look at precipitation, again, large changes, generally positive changes, are actually all positive changes in precipitation, but less than 10% on average annual precipitation. If we kind of go down to a finer scale in the ClimAid report, here's an example from one of the regions. This actually is the coastal region, including New York City. And again, basically what we show in our report is over those models, kind of the worst case scenario. So warming in New York City here on the order of, if we look at the current day value of about 56 degrees Fahrenheit, in the worst case scenario, we're looking at average temperatures in New York City that are actually 12 degrees warmer than they are now. In the least worst case scenario, we're still looking at temperatures that are on the order of 2 to 3 degrees Fahrenheit. Most of the models are falling in this kind of pink band, again, on the order of 5 or 6 degrees Fahrenheit warmer in the city. If we look at precipitation, here's the Adirondacks region as an example, and the same type of thing. We can see that in the Adirondacks, looks like my slide got cut off here. In the average, we're here around 40, so on the order of maybe a 20% increase in the worst case scenario, or a slight decrease in the lower emissions scenario. So again, giving you an idea of the magnitude of not quite sure how precipitation is going to go. We look at this through time in temperature. I'm going back to temperature, so kind of see our three time frames that we looked at, kind of a near term, a middle term, mid-century, end of the century, temperature change across the state or the region here from the climate assessment. Basically, A2 is a high emission scenario. That's the track we're on now, versus B1, which is a lower emission scenario. That's basically if we keep our emissions constant as they are now. And we can see by the end of the century, huge changes in the difference. I mean, just by the color of these maps, you can see in this high emission scenario, we're much worse off looking at changes on this order of 7 degrees versus in the lower emission scenarios, we cut that back by 3 or 4 degrees. Other thing to note is not much difference in the near term. The big differences show up in the longer term. So this idea of being locked into a certain degree of climate change, really not, even if we stopped emitting greenhouse gases today, we still have impacts to worry about. See the same type of thing for precipitation. Again, increases across the state, no places in the region showing decreases. Look at the seasonality, warming in all seasons. And actually in our model projections, unlike the observations which show the most warming in the winter, our model projections actually show more warming in the summertime. And this is a consistent result across a lot of studies. So might not be the winter that we have to worry about as much as maybe some of the feedbacks die out in the coming years, but really a big change here in the summer. And looking at precipitation, most of those precipitation changes come in the wintertime. The increases are in the annual or winter months. And if we look here in summer, this is the zero line basically, equally likely to have increases or decreases. So this is this idea of, potentially having more droughts, having water shortages for things like agriculture because it's really focused on this time of the year, despite having more rainfall. Kind of pick up on some of these and kind of play the game here of looking at what we see in the national assessment in terms of changes in some of these more extreme values, and then kind of pulling on the ClimateAid report and looking at some of the impacts that we've seen from there. So for heat waves, again, we can see increases in days above 95 across the entire region. So basically, my next few graphics, this top panel is going to represent the change in the number of days. And then down here in the bottom, what I've done is kind of given you the climatology, what we normally see. So if I look at, say, Tompkins County, it's very rare that we get a day above 95 in the summertime. But if we look into the future, we could be on the order of, again, I can't see my numbers that closely here, I think 3 or 4 days above 95 in the summertime. The city gets a lot worse here. We're talking about months of days above 95 in the summertime. So anyway, we see heat waves becoming more frequent, more intense, more heat-related illness and death. We see more deaths, weather-related deaths in summer due to heat than we do in the winter, say, due to cold. Definitely challenges on our energy systems, right? Most of our energy peak loads are in the summertime for cooling. That's only going to get worse. Air quality is exacerbated by these high temperatures in our city and the obvious agricultural implications of hot and dry summers. We look at winter temperatures, days below 10 degrees C. This is the normal climatology here, and we can see, particularly as we move north into the Adirondacks, huge changes in days below 10 degrees. Normally, what we normally would expect to see in winter, again, I can't see my numbers that well, but it looks like almost a month less of days below 10 degrees. Obviously, impacts there having to do with tourism, right? If we're looking at winter skiing industry or snowmobiling industry, clear impact there, and large impacts on the ecosystems in that region. I guess my milk production, I don't know why I put that there. That actually goes back to that summer heat, and we see that as an ag impact. I'm sure Dave will speak to that in the next one. Opportunities, though, growing season length increases. Okay, so one of the big impacts we see here is an increase in our growing season length, perhaps opportunities to capitalize on double cropping if we're in ag production. If we look at it, it was funny, last week I was in Washington arguing for funding for the Climate Center and met with our local federal representative, and basically said, I hear that there's opportunities. I hear climate change is going to be good for my district because I hear the grape industry is going to do quite well. And it was nice to be able to say to him, well, yeah, that's exactly right. That's actually a result out of the New York Climate Report that we were involved in. And yes, there are opportunities there for the grape industry. Better varieties of wine, more European varieties of wine. Our competitors do worse in climate change than we do. So again, keeping in mind that we're looking, in viewing these impacts, we should be prepared to deal with the negative risks, but we also should be prepared to take advantage of the opportunities that might be there. Again, precipitation, days with greater than an inch, a huge increase in these heavy rainfall events that we see across the Northeast going on into the future. We're definitely looking at the impacts here. Flooding impacts, effects on our water quality. Heavy rainfall events tend to put more pollutants into the water, more perhaps foodborne or waterborne illnesses relate to these heavy rainfall events. And clearly our aging infrastructure is at peril here with these high rainfall events. Summer drought, also an issue again, looking at that variability in the summertime. And we can see the number of days in the row where we have essentially no precipitation increasing. Snowfall, our snowpack goes down as I'm getting the time message here, and sea level rise. So I'm going to kind of skip that, and I do want to go to basically here. I want to end with saying that we can't look at just climate change with our blinders on, okay? We have to look at a lot of other things, and particularly when we look at the interaction, or look at the impacts or the stresses of climate change, there are a lot of other impacts that are going on, a lot of other stressors that are going on. So we have to look at invasive species together with climate change and things like that in terms of looking at the risks, looking at the vulnerabilities, looking at perhaps the way we can adapt to climate change. And then I'd like to leave off here with just the southern tier out of the climate report. That was the region Tompkins and Cortland counties were in. And these were basically the highlights of the impacts that we felt we saw from this region. The dairy industry, perhaps the agricultural industry that has the biggest impact, flooding, particularly along the Susquehanna, which has had a history of flooding events, and also invasive species. As these insects and other species diseases move northward, this would be the first place we expect to see it in the state. So I will move on to David.
Great, thanks. Well, while it's coming up, I'll just say thanks to all the organizers for inviting me. I had a great time yesterday, actually, with the ag session that Frank Kelly and others put together out in Cortland. I was able to get into a lot of details there. Here, with my 10 minutes of fame, I'm not going to have too much time to get into a lot of details, but we'll cover agriculture as well as a few other things, the ecosystems and urban landscapes, too, at the same time. Also, it's kind of interesting, Art and we've done our dog and pony show for many years. I usually follow Art, but this is kind of a little bit of a unique event. I really think it's really cool what's going on here. I mean, it's a multi-day event, and so many, such breadth in terms of the community members involved. It's a very, very interesting thing what's been done here. I'm very glad to be a part of it. On this first slide, I just want to point out the climate change website at Cornell, climatechange.cornell.edu. There's a lot of fact sheets and resources there. I brought a few of the fact sheets with me out on one of the tables out in front. Also the climate report, which has been mentioned several times, there's a link to that. If you don't want to read that whole big book, you can just go there and you can download certain chapters or scan them. Something to check out. This is another way to show climate information and something that's more familiar to at least like the home gardeners in the audience and farmers. This is the plant hardiness zone map. This is something that's at most garden centers. Most farmers look at this sort of thing. Color-coded map based on how cold it gets in the winter, the coldest it gets in the winter, which really tells you a lot about which ornamentals you can grow in your home garden, what crops farmers might be able to grow, but also has huge implications, for example, for the habitable zone of all kinds of species, including insect pests in our forests and farms, et cetera, and how these climate zones are shifting so quickly. You can see both of these were created the same way based on just weather station records, looking at the last 15 years of weather station records. The map on the left done in 1990 and then in 2006. Not long after, you can see how no matter where you live in the US, your climate zone has shifted. I have a study with the New York Botanic Garden in the Bronx where we put in a test garden several years ago, planting everything based on the 1990 map that was one zone warmer than where they were rated, and those things are surviving. The key thing though is, as an ecologist, I look at that and I go, the problem is, as those zones shift, some species might follow that, but they're not all going to follow en masse. You're not going to have, complex ecosystems move en masse tracking this zone. So as I'll mention in a slide to come, we're very concerned about disruption of important species interactions. I also want to mention the pace of that change. So seeing that kind of, the climate's always changing. On my course on climate change and the future of food, we talk about how the climate's always been changing, but it's the pace of the change we're seeing now. This kind of change typically might take several hundred or thousand years that we saw in just these few years. The numbers that Art talked about, the projections for the next 50, 100 years, the 8 to 12 degrees Fahrenheit on the upper end of that, that's the same magnitude of change that we saw since the last ice age transition. So our climate isn't changing a little faster than it did since the last ice age. It's about 50 to 100 times faster if you do the math. Something interesting to me, something that really kind of affected me personally was when we did a study, we dug up some historical records of lilacs, apples, and grapes, their first bloom dates in the spring. Going back to the 1960s, and we documented that right here for our region, we are indeed seeing a trend for earlier bloom dates of these. Just indicating to me that the living world is really already responding to the climate change we're seeing. And actually these perennial plants, you can also look at as like very sophisticated weather instruments, really. They integrate the whole winter period. They keep track of winter chilling hours. They need a certain amount of winter cold, actually, to bloom properly in the spring. And then in the spring, of course, they count the degree days, the warming up. So they actually give us a lot of information. And there's just now, in the peer-reviewed literature, thousands of reports of the living world responding, everything from birds arriving earlier, insects arriving earlier, and all kinds of things. One thing with those climate zone shifts we're seeing, of course, is the potential, and in some cases the actual observation now of species moving with those things. And our big concern, of course, is for aggressive invasive species that might wreak havoc on our natural ecosystems of farms. On the left, hemlock woolly adelgid. Hemlocks are an evergreen in this part of the country, which are very important evergreens to, particularly along the stream banks, et cetera, very important ecosystem function. They have been destroyed by this little aphid-like insect south of here, and this isn't true for all invasives, but for that particular one, the hemlock woolly adelgid is indeed responding to climate change, moving northward into our area. So even while our hemlock trees might be able to withstand the climate change projected for our region, they're going to be subject to that damage. On the right, you see anybody who's been in the South or from the South will know about kudzu, very famous. You can see what it can do, a big monstrous aggressive invasive weed. This is some modeling work we did some years ago on the bottom panel, the bottom right panel. The dark orange going from left to right is showing the Northeast, and the dark orange is the habitable range for kudzu, basically kudzu coming to get us. The top panel there is the higher emissions scenario, and the bottom panel is the lower emissions scenario. So a farmer response to this, of course, is going to be using more chemicals possibly, and we have to worry about this kind of unintended consequences of adaptation, trying to give farmers the heads up on this so we don't end up with more chemicals in our waterways, giving them alternatives to controlling these things. Now, Art was very concerned about his winter skiing with snow, but I wanted to talk about this whole area of ecology called subnivean ecology. There's a lot of things live under that insulating blanket of the snow, and they're dramatically affected by the snow. We've pretty much lost the Canadian lynx from New York, largely because the creatures they like to feed on, the little voles, et cetera, under the snow, have a harder time with less snow cover that we're already seeing. Deer, on the other hand, now I'm one of the few people in Ithaca who likes deer, but they happen to be a big winner when it comes to climate change, not only because the winters are warmer, but with less snow cover, they can eat more vegetation all winter. And we just witnessed right outside of my back window this last year, twins born. And there are more twins being born because they are eating more in the winter. And they have a huge impact on plant community structure and all kinds of impacts on ecosystems. One of my own graduate students did work on soil microbial ecology as affected by snow cover. One of these grad student projects, he was out there shoveling snow from certain plots all winter. It wasn't a fun project, and I can't go into the details of that, it would take too long, but nitrogen retention in our soils, the whole nitrogen cycle affected by microbes is subject to the snow. We have to really expect the unexpected. I didn't really expect when I got into this 20 years ago that one of the biggest demands I would have from farmers in terms of talking about climate change would be talking about more freeze and frost damage. And we actually are seeing this even in winters where they are warmer than average. If you take the December plus January plus February temperatures, but the winter, when it gets warm and cold in the winter, has a huge impact. In this case, last year we had a 4-week earlier than normal apple bloom date, a long window of time with frost risk, and lost 30 to 50% of our apple crop. We're second or third in the U.S. in apple production, tens of millions of dollars lost. As I mentioned already, what we're worried about is that, just like every human's going to respond a little differently, uniquely to climate change, every species out there is going to respond uniquely to climate change. And if, for example, you have a plant that's bloom date is changing in response to climate change, but it's a highly specialized plant, requires a highly specialized pollinator, and that pollinator doesn't respond in exactly the same way, they're out of sync, and it could, wreak havoc on those kinds of things. So, big area of research in ecology, and something we still don't know a lot about, but we're very concerned about. So, in terms of our ecosystems, they are going to change. That's something, in climate change literature, we use phrases very carefully. What things are we highly certain of? Which things are virtually certain? Which things do we have some level of uncertainty about? Which things are likely? Our natural ecosystems are going to be changing over the course of our lifetimes, and certainly as our children grow up in there. And what are the ecosystem services? Everything from tourism dollars to things like habitat for other species, our water quality and water supplies, and so certainly very concerned about that. I've got just one graphic showing some details about what it might mean for our forests in this part of the world. The panel on the left, the upper left picture is kind of a color-coded map showing the current tree species distribution. The gold color is maple beech birch, which we all know is what really kind of dominates. You might be able to notice a little splotch of a dark green there. That's our spruce fir forest in the Adirondacks. Notice one of the more serious tragedies for me personally, because I happen to like the Adirondacks and like those spruce fir forests, is even under the lower emissions scenario, which is the second map down there, we lose those spruce fir forests in terms of our climate being suitable for them to grow well. Now, this is just based on the climate and soils, saying that the climate will no longer be optimum for these tree species. And oak hickory pine in the bottom panel, the gray area, is oak hickory pine coming up to replace the maple beech birch. But we don't really know that that's going to happen. The climate will be more suitable for oak hickory pine and not these others. But to really think we're going to have this neat little, this species goes out and here comes the perfect little tree species that's going to replace the function that's something where we have virtually no certainty about. In fact, all I can say about this is what I've got there in sort of big letters on the upper right. All I can tell you with a high degree of certainty is those natural landscapes out there are going to be disassembling. And they're going to be reassembling in new ways. And if there's an ecologist who tells you he knows what they're going to do, he's full of it, I would say. We really don't know what's going to happen. We have some concerns. One of them is on the bottom here, what's going to happen to, in terms of invasive species. It could be that instead of some nice tree species that we might like as a replacement, we end up with some very aggressive invasive, and that's going to be a big problem for us. And how do we manage all of this, et cetera? So some big challenges. For farmers, we have some opportunities, as Art mentioned, and I don't have time to really go, I went into a lot of detail with that yesterday. The grape growing is one example, longer growing seasons, relatively water rich, so compared to some other places in the world where I give talks to agricultural audiences, where it's pretty much doom and gloom. I've got a project in Ethiopia where it's nothing but rainfall going down there, and it's already tough enough for them. Some real challenges. But here, even here, we will have some challenges with more insect weed disease pests with these warmer winters, more of them surviving, more challenges, both too much and too little water, and the heat stress issues for our dairy industry, as was mentioned, et cetera. The big problem for farmers in terms of adaptations, and again, yesterday I had time to go through some details of the adaptation strategies for farmers, is when to strategically make those adaptations. Trying to separate out the noise from the noise of normal weather variability from the actual climate change. And we're working at Cornell for better decision tools for farmers to work through some of those things. So I wanted to say a couple things about in the urban area in terms of adaptation. One example is we have issues of more heavy rains and flooding, and there's a lot we can do. Anita Bassick, for example, at Cornell in the Urban Horticulture Group, has done a lot of work with structural soil and porous asphalt, which are examples of ways we can allow good drainage instead of all these impermeable surfaces in urban environments really lead to more flooding. You have to have better storm water drainage to maintain all of that, and that's one example of an adaptation at the urban end of things. I guess since I'm been told I'm running out of time, I'm going to have to possibly stop it here. But one incentive we have for mitigation in addition to adaptation, so mitigation is really this thing of managing the unavoidable, as Mark, our guest, has talked about, is this thing that, these things that happen far away from us, we're not really exempt from those. So while we look at something like Hurricane Sandy and say, well, thank goodness we're not on the coast, but that is really diverting huge sums of money, tax dollars, away from sustainable projects, away from the kind of things this community wants to do, and towards infrastructure repair, humanitarian assistance, and that sort of thing. The droughts we saw last summer didn't have a dramatic, huge effect directly on us. Here, some of our farmers got through it okay, but increased food prices are the kind of thing that we have to think about. I had a few slides on mitigation, but I think I'll cool it with that, and we can leave that for the discussion at the end. Thanks.
Good morning, everyone, and I'm also really happy to be here and part of this event. I think it's a wonderful opportunity for the community to come together to really think about climate change from a number of different perspectives, and I'll be really talking about climate change more from a social perspective as a social scientist that's been investigating these issues. So some would say we have a climate crisis that, we have heard the data from Dave Wolfe and Art DeGaetano. We know that average global temperatures have increased about 1 degree Celsius over the 20th century, and that the last 2 decades were the hottest in the last 400 years and possibly the warmest for several millennia. And we know that according to the UN Intergovernmental Panel on Climate Change, this has been, the last dozen years has really been the warmest since the mid-1800s. And the United States, so what's our role in this in the US? United States contains only 5% of the population, but of the world's population, but contributes 22% of the world's carbon emissions. And so when we think about this climate crisis, it really comes down to, in many ways, what that really means. And so let's think for a moment about the etymology of the word crisis, which actually was medical in its original origin. And it was defined as the course of a serious disease at which a decisive change occurs, leading either to recovery or death. And the modern definition of crisis is a sequence of events at which a trend of all future events, especially for better or worse, is determined, a turning point. And so when we think about this climate crisis that we're currently experiencing, it's really about that point that we're at right now, that potential turning point at which we determine the future. And so what does this crisis look like? Well, we know from the many events that are listed here by NOAA that we've really had a number of extreme drought, heat waves, floods, tornado outbreaks, hurricanes, wildfires, and other winter storms that have caused billions of dollars in damage and more regrettably, loss of human life and property. For example, Hurricane Irene in 2011, struck as a Category 1 hurricane and made landfall in New York City. And that rainfall was $7.3 billion in damages and 45 deaths. And so there are many human consequences to climate change. And so the top left photo here is a island in Spain, Palma de Mallorca. So you see the snow and ice there. Of course, Washington, D.C., we remember Snowmageddon in D.C. that shut down our federal government for a week. The bottom left photograph, 35,000 people in Romania were isolated from both food and water. 16 people died over 2 days. On the Black Sea, the bottom right photograph shows temperatures inland that dropped to negative 34 degrees Celsius. And so my question in this as a researcher and someone doing outreach is really, what can we do about this climate crisis that we're experiencing? And I would argue that local really matters in climate change. That local governments have a very significant role to play. As much as the global and national political context is important, I would argue that places like the 62 counties, 932 towns, and 62 cities in New York State that control energy use, infrastructure, planning, local roads, or making land use decisions, that these are the critical and pivotal actors in climate change, but they're relatively understudied when we look at a lot of the research has really examined more of the larger cities, and when we're looking at things at a town or village level, we're really, I think missing some of the key actors, and cities and towns are very, very pivotal, and we see that from my perspective, it's very important to understand what motivations there are for climate protection policies at the local level, as well as what communities are doing to plan for climate mitigation, for the potentially increase in precipitation and temperature. And so my research and outreach is really focusing on understanding why some communities, especially those that are vulnerable, are better prepared for extreme weather and other natural disasters, and how to encourage more widespread climate change mitigation and adaptation actions. And so I'm working on this with a research team looking at municipal officials in New York State, and we conducted a statewide study to look across New York. We did a quantitative survey of mayors, town supervisors, environmental management council members, conservation advisory council members, surveyed over 1,000 of these individuals across the state to find out what actions they were taking with both with regard to climate mitigation and climate adaptation. And one of the results that we found, we really wanted to look at what communities were feeling and experiencing in terms of the predictions. So based on the data from the models that Art really outlined are across the x-axis of this graph. And so, things like increased sea level, increased winter temperatures. And we asked both about the relevancy, which is the green bar, and the perceived vulnerability of their municipality for these events that are forecasted under a regime of climate change. And interestingly, the ones that were considered most vulnerable, most relevant, and most vulnerable for municipalities in this study was really the increased frequency of extreme weather events, as well as increased precipitation and flooding. Also drought and increased summer temperatures. So, it was interesting that from the perspective of municipal officials in New York State, they really think that these projections coming out of the models are both relevant and that they represent vulnerabilities for their municipality at the local level. And let's think for a moment about attitudes, because in many ways that's related to the actions that we take. And we did find that a majority of the municipal officials across New York State either agree or strongly agree that the science shows that the climate is changing. They agree that there's sufficient evidence that over the coming decades, climate will impact their municipality, and that they're already seeing evidence of how climate is changing. And so these were well over 50% of the population, up to 70, 80% on some of these items. But most of the municipal officials disagreed or strongly disagreed that there was sufficient information on how to address local climate impacts at the local level. So their attitudes were in agreement that climate change is happening, the science behind that, but they really lacked the information about what they should be doing at the local level. And then we also found that only about 26% of municipalities across New York State were taking any actions with regard to climate, and that was climate mitigation or climate adaptation. And so we see that the majority of municipalities really aren't taking any actions, at least for those participants in this particular study. And so we found that in terms of the actions that municipalities were taking, things related to mitigation were realizing energy savings in buildings, investing in transportation, renewable energy, adopting the Climate Smart Communities Pledge, investing in energy-saving water and industrial waste processes. And climate adaptation actions were things like, developing climate action plans, planning for and selecting for specific adaptations, and developing planning on long-term horizons greater than 10 years. Again, because many of these changes are going to be happening in that time frame. And so if we look at what influenced action, so we were able to model what factors influenced those 26% of the municipalities that were taking action. This is something that was very intriguing to me, is, why are some municipalities taking action? And the ovals represent the mean scores of these influencing factors. So was it leadership? Was it, did they take action because it made economic sense? Those are the fiscal savings. Did they do it because they had the right cooperation and partnerships to do it? Did they do it because their constituents pressured them to? Or was it more of a top-down mandate that they felt that they were required to do? And so these were the factors that influenced action. And in terms of the mean scores, leadership came out as the highest mean score in terms of factors influencing action. And so that was really the primary influencing factor. And when we modeled those factors with specifically mitigation actions versus adaptation, we found that leadership and cooperation were the significant variables in that equation. So when it came to mitigation, those were the key factors driving action. When we look at adaptation, it was leadership and then having this top-down mandate. So having a leader that says, you know, this is what we will do. And so those two things really played more of a role with adaptation. And if we look at another factor that is interesting when it comes to why municipalities are taking action is this degree of rurality. So whether it's an urban area or whether it's a rural area, and these are census designations based on the population of a location. And so urban centers are areas with 50,000 or more people living in them, places like Ithaca, Rochester, Binghamton, Syracuse. Urban clusters are those between 2,500 and 49,999. So these are small cities like Auburn, Bedford Hills, Chittenango, Owego, places like that. And rural areas, interestingly, the census defines as any area that is not urban. So places like Hoosick Falls, Otsego, LaGrangeville, places like that are rural areas in New York State. So interestingly, I had this question of, well, does this play a role in municipalities taking action, the degree of, the size of the municipality? And certainly we found differences when we looked at these three types of urban areas, that it really was the urban areas that were taking more action. And just to conclude, I would say that we found that with regard to attitudes, the rural areas were, rural municipalities were significantly more likely than their urban counterparts to believe that there was no need to address mitigation or adaptation and that climate impacts were exaggerated. So we did see some interplay between attitudes and actions for the rural municipalities. So significant differences there. And I guess just to conclude, this coming back to this idea of crisis is that municipalities, whether they're urban or rural, I think are the linchpin in climate change, because these are our local municipalities that are making land use decisions. They're managing local infrastructure, and I think really need local tools to be able to plan for what the future will hold and adapting to these changes that Art and Dave so eloquently laid out for us. Thank you very much.
Thank you all. Like Shorna, I'm also a social scientist, and because we actually tend to play in a lot of the same sandboxes, we actually met ahead of time and tried to coordinate a little bit what we were talking about so we wouldn't say exactly the same thing. I titled my talk Community Planning, Climate Change and Uncertainty in a Home Rule State. And I'm going to draw as much from my experiences as an appointed official and volunteer planner as I am on my research and work at Cornell, because I think they're equally valid. And I'm also going to I state what to me is the obvious, but may not be to others until I start talking, which is that I have almost no expertise that I would claim in climate change per se, unlike particularly the first two speakers. But I have looked a lot at the other topics that I'll talk about. I'm going to talk about two major themes, and what I'm really trying to do is just introduce some ideas that need a lot more thinking as we move forward. And one of the key ones, which we've already heard a lot of discussion about, is the difference between risk and uncertainty, and the importance of planning for that. And you know, the idea of risk, which is we have a lot of work on risk. We know a lot about how to handle risk, and you know, the sort of the paradigmatic idea of risk in a sense, is probability. Many of us study statistics in school, and the coin toss model is what we usually see. So while we don't know what's going to happen with any given coin toss, is it going to be heads or tails? If we get enough of those coin tosses, we have a pretty good idea about how many heads and how many tails we're going to get. And that's something that is a certain kind of planning that's relatively easy to do. Planning for uncertainty is very different because by definition that means we don't really know. And we heard a lot of discussion from our first speakers about some things that we know quite a bit about are very likely to happen, although we don't know exactly when or where necessarily all the time. But there's a lot of other things that are coming along where there's a huge variance. We just don't know. We just really don't know yet what's going to happen. Dave, I think, especially emphasized that. So, here's an example of sort of a risk framework that's taken into planning for flood from the USGS, and something that municipal officials and the insurance industry always have to deal with, dealing with flooding issues. This is a southern tier picture. The key thing here is, based on historical data. We actually look to the past to try and understand what's going to happen in the future. What else can we do, right? This is interpretation in terms of probability, not in terms of uncertainty. And I wanted to introduce some policy now that has been adopted just last year at the national level by the absolutely marvelously named Biggert-Waters Flood Insurance Reform and Modernization Act. And there actually are 2 congresswomen with those last names who were probably put together by a PR firm. So, and basically what this is about, and this is like a headline from a place that cares a lot about flooding, which is Louisiana. But the basic idea is if you live, below base flood elevation, the subsidy that we've all been giving you in your insurance rates is going to be phased out fairly rapidly. These are just some details about what that act is actually who it's going to affect. It's not going to affect in the very short term homeowners who are just in a risk area, but aren't doing anything, aren't changing ownership. But it's going to affect almost everybody else. And as soon as you change ownership of that property in any significant way, or as soon as you're flooded, as soon as there's a risk event, you're going to be affected. So, what are the implications for planning of this? We got to figure out who's most likely to be affected. And, I've been involved, and people I work with have been involved for many, many years about flooding kinds of issues. And, we've been sort of from a policy perspective saying you got to move out of the floodplains for a long time, right? But, when you actually start thinking about what does that mean, think about the impacts on lower income people. Think about the impacts on, in terms of racial divides in our country. It's not, think about what happened in Louisiana. Should the Ninth Ward rebuild or not? These are not simple policy problems to just say because climate change is happening, we have the right answer about what should happen. This is now moving into a little bit about uncertainty instead of that sort of risk framework. I just want to say, I think people are just really starting to think about this issue in a serious way in a climate change framework. And, here's one paper that I read on this topic. I think the important thing is, particularly the end, to allow for dynamic adaptation over time to meet changing circumstances. But do not use the fact that we don't know. And I think, again, the earlier speakers talked some about this, that we don't know exactly what's going to happen to just be paralyzed. We need to act on the basis of some things that we know and can anticipate as well as possible. So here are just some ideas, I think, that at a at a planning level that we ought to be thinking about when uncertainty dominates. We ought to focus on decisions and variables that have large influences on outcomes. And I think there's a new science that really has to happen, or we have to become more familiar with, to help us understand what critical tipping points or crises, what are the big factors in the crisis, if you will, as one of the earlier speakers was talking about. We need to be extra cautious about large, irreversible resource commitments, because we start going down one path, we may learn that we didn't do the right thing. So if it's irreversible, we've committed those resources already. And especially we need to really and this is very good for academics, I might add, but we really need to upgrade our monitoring, analysis, evaluation capacities in a way that is, because we can't just assume that because we looked at it once, we actually know where we're headed and what's going on. I just threw this one in here because I think one of the wonderful things about climate change has been the boon it's given to graphic artists for trying to help us think about what it means. And I'm going to talk a little bit about the home rule part now. That's the second theme I really want to touch on. So here are some, based on my sort of local involvement, some things that are things I think we need to think about in terms of regionalism, home rule, and climate change impacts. One of them is I've been somewhat involved in the project to dredge the flood control channel, and what are we going to do with the dredge spoils. And I think we all know, we have for some time, that water flows downhill and it doesn't stop at political boundaries. So in this context, what does that mean? It means that the sediment that has been filling up the flood control channel since the last time it was dredged about 40 years ago didn't originate in the city of Ithaca. So start thinking now about climate change, which part of, I think, what it means is there's a lot more energy moving through our water courses, and a lot more energy. I don't know anything about this. I just sort of like, in detail, I just sort of like, therefore, there's a conclusion. There's going to be a lot more sediment probably ripped out of the walls of the water courses, and it's going to end up downstream, and it's going to deposit in the city, which is responsible with all these other agencies for figuring out what to do about that. And notice that the upstream municipalities are not listed there. Here's another one, lake level. So many of you may remember, if you've been here as long as I have, that there was at one point you could actually go fishing in the parking lots down there where Wegmans and Tops are. That was caused by, that flooding was basically caused by lake level, high lake levels. Who controls that? Essentially the Canal Corporation at the other end of the lake that determines how low to lower the water levels in anticipation of the water which will be coming into the lake. And of course, everybody on the lakeshore has a stake in that, as well as those of us who live just here down at the end of it. And, there are reasons to lower the lake in anticipation of more water. There are reasons to keep it higher in anticipation of less water. And with uncertainty, what are we going to do about that, right? It's a problem. There's not a good, perfect answer. Since most of my work is around land use, I'm just going to throw up a slide. I don't have really time to go into it, but to remind people that smart growth, which is really about where does development get focused in our community, and something that I know many people in the room have done a lot of work on in the planning community, and I've really spent a lot of time on. Smart growth is a really important policy tool to think about in terms of both mitigation and adaptation. Mitigation in the sense that it has the potential to reduce greenhouse gas emissions, smart development patterns. Adaptation in terms of it has an important ability to respond to what we know is going to be inevitable to some extent. And I want to raise kind of sort of more philosophical questions about, in a sense, identity questions about the whole issue of home rule and regionalism, because I see a lot of tugs and pulls in a lot of different directions about this. And I think we as a very progressive community can be very rightly proud of the things that we're doing here. And I certainly am proud to be a part of that as much as I can be. But one of the things I always am concerned about is that we don't let our pride in ourselves go too far in the direction of forgetting about how we're interacting with the rest of the world. And, and I think there are many ways to think about this, and I just want to point out that in a state, as Shorna said, that has about 1,600 local governments in it, which is our sort of our public presence in terms of policy, we can't solve the problem just here in Ithaca. Time? Okay. So I will just go on to skip that one, just saying that there's a long ways to go in terms of what municipalities are doing in terms of comprehensive planning, and that there are a lot of local planning efforts, both, and I've been involved with the city and the town in particular, and we need to get involved in them, all of us collectively as citizens, with a framework of climate change in them, because that is, we're discovering how to think about what does it mean in terms of planning. So there's another local planning, that's the cities. We just got a sustainability audit back, which is a really interesting series of documents to look through. A lot of people who are interested in that should get involved in looking at these kinds of things. And I just want to raise at the very end here, this is based on something I wrote recently about energy federalism. And what I want to highlight here is there are benefits and costs to doing things centrally and collectively. And there are benefits, and if you want this stuff, you can get it and read it later. And there are benefits to doing things and costs to doing things in a very centralized, decentralized way as well. And all of these things are things that I think if you think about them in the abstract, you will relate to, but become problematic when you start trying to apply them in a particular place, like what's the right answer in a particular issue in a particular place. And again, I don't think there's enough thinking and dialogue about it. I think we have to get more reflective and less reflexive about these kinds of things. So I'll stop there.
Good morning. Everybody ready for the next phase here? Are all the speakers up here? Yeah, thank you. Art and David and Shorna and David. Now, which is our order here? So Shorna, David, Art, and David. Okay. My name is Mark Hertsgaard. I have been here for a couple days now and am learning a lot, including here this morning. And I'm going to moderate this next session, which will go on until 10:30 or 10:15? Oh, it's 10:30 now. Okay, 10:45. Another 10 minutes. Okay, so those of you who have questions, why don't you prepare and stand up, and you can give them out. I want to just follow up really quickly with a couple of things, points of information. David Kay, you mentioned the Biggert-Wahlert Flood Insurance Act. Has that been passed? That is now federal law? That is
2012.
As of 2012, and the president signed it.
Someone in D.C., I learned about this about a few months ago from someone in D.C. He said, the rest of my career is going to be spent dealing with very angry people who are going to have to live with this.
Boy, that is really something that has slipped under the national media radar. I mean, I covered this issue. I did not know that that was law. So,
I don't know anything about the legislative history or...
But it has been signed into law by the president.
My understanding.
Yeah, okay. All right, so...
Anybody know differently?
No, but the 11 o'clock session, business track, is all about insurance.
Well, presumably they'll know about that then. Okay, so yeah, why don't you go ahead and then here, and hopefully if you can keep your questions short and the answers short as well, and please don't all four of you feel that you have to comment on every question.
My name is Sam Gordon. I work with the Regional Planning Agency in Syracuse. I had a question for Shorna. With the research that you did, I'm curious as to know that 26% of the municipalities, what percentage of the total population of New York does that represent? And related to that is the relation of staff size at the local level to this action.
Yeah, that's a great question. We haven't actually extrapolated out to see what population is represented by the municipalities, but that would be actually really useful. So thank you for giving me more research to follow up on. but I guess the second question about staff capacity, that was one of the reasons that we saw that the difference between the urban and rural municipalities is that it comes down to capacity, that urban municipalities just, they have larger population, larger tax base, and so more resources, and so they're able, I think, to, to have more staff, and so we did see a relationship between that in terms of the capacity. Great question.
Also, one thing, Shorna, I noticed that you mentioned the role of leadership, which I think is something let's emphasize here in this room. If you have a leader, it makes all the difference. That seemed to be the decisive factor. So it's not like you need to have the majority 100% support for this. One person who can lead and a small number of people with him can really make a difference. This person and then here. Go ahead.
So this question was triggered by something in Shorna's presentation, but all of you can address it. So the conference is called Climate Change, which is kind of a neutral, some things are good, some things are bad, things always change. But you use climate crisis. Did you use that for a specific reason, which is not a neutral term? Should we be using that term rather than what we're calling it?
Very intriguing, the term crisis. So I guess I did bring that up because in terms of what municipalities were telling us, I didn't mention this, but we also did followed up with interviews, and so we were able to talk firsthand with municipalities, and some felt that way, that that in terms of some of the extreme weather events, that they were making the link to climate change. And they felt like their municipalities were in crisis. They were, having to deal with floods. They were, under 4 feet of water and forced to really think about these issues.
Really quickly, anybody else here, do you say climate change, climate crisis? I've heard from scientists who say we should be calling this climate chaos. Or climate disruption is a new phrase that a lot of activists want to use now to try to convey, although I would say, sir, I think climate change, that is the scientific term, but in terms of the public discourse, why don't we go down the line and really quickly say climate change, climate chaos, climate disruption?
I certainly like, compared to global warming, I definitely like climate change because it's not just about the temperature. There's a lot of places where it's very complicated what's happening with the climate, a lot of unexpected surprises we're getting. In terms of crisis, that's I kind of lean more in terms of the other ways of fine-tuning what we might say about climate. The crisis, then you end up with the sky is falling type of notion. And so I guess, lean more towards communication people helping me decide for different audiences what might be the appropriate thing. Climate disruption, I happen to like a little bit more than crisis. In terms of a lot of the audiences I go to, I think if I were to talk about crisis, they would kind of get a little numb to the whole thing.
How about you, Art?
I like climate disruption out of all those cases. I guess that I agree with exactly what Dave said about climate crisis. I think that's perhaps too strong of a word, and actually I think will turn a lot of the audience off. It might go over well with some groups, but not in other groups. I think addressing the disruption part.
Disruption. And the second, David K.
First thing I'll say is, in working with some of Shorna's colleagues trying to write surveys on this issue, it's a very hard thing to know what term to use. And I agree with David. I would want to contextualize my answer to depending on what audience. And the difference for me is, I think crisis is a word. Crisis is a word and a concept and a thought that people who aren't thinking about something will start to pay attention to. I actually think it's the wrong metaphor to do at least what I want to do, which is long-term planning. So I would want to move people from thinking about crisis to thinking about some of the other things.
Climate disruption?
I'm happy with that in some context.
I must say that increased.
Let me just say, I start from trying to listen to what audiences care about and trying to communicate with them. So I'm going to use a term that seems like you can relate to and that we can have a dialogue about.
Yeah, I must say that's, for me too, as a journalist, somebody who's been trying to convey this for a long time. Over time, I have come to think that climate disruption is really the the best all-around term because it does get people's attention. It is scientifically accurate, and it does tend to sort of open conversations rather than shut them down. Frank, you had a question, and then this lady.
And I do think that what we're talking about here, this is sort of a follow-up, okay? I think the way we communicate concepts is important, and I think the way we conceptualize concepts are important. They're not the same thing, even though they're overlapping. So I'm wondering, Shorna, how you defined and operationalized leadership in your research.
Yeah, I wondered that same thing. What is it? Does somebody define themselves as a leader, or what?
That was a composite measure that was based on a response to a set of questions about what influenced action. So whether it was someone in a leadership position that took the initiative. So that's how it was defined. Someone taking the leadership to initiate, maintain, or sustain a particular action.
Okay. I will just add quickly there, some of the best work I think being done now in the world on adaptation is coming out of Britain. And the guy who heads that talks about the role of leadership and says that they're really, it's very much in line with what you're saying, that there is no substitute for that. That if you've got somebody, he said, in fact, he would go so far as to say that in any institution, whether it be government or educational institution or civic or corporate, that if there's not one person who is at the top or near the top of that organization who can say, climate adaptation is central to the functioning of our organization and to our prospects for success in the future. Somebody who's a member of the board or a member of the central governing committee who can make that stick, that in their experience in working with cities and municipalities in Britain, if you don't have that, it's not going to go anywhere. So as important as it is for all of us to get involved, it's really important to foster leaders, to nurture young leaders, to push people forward who maybe have leadership qualities but are perhaps a little shy about showing them. We need leaders. There's nothing wrong with having leadership. There's oftentimes on the progressive side we think, oh, we all have to be, equal in consensus and all of that. That's not necessarily borne out by the data.
Yeah, I'm Carol Chalk. I'm on the Tompkins County Legislature, and I was interested in the points that Dave and Kay alluded to at the end about the need for both a look at decentralized and centralized decision making. I'm interested in how do you figure out at what point you can influence the system that's so built in to perpetuate what we've got. So here in our region, we've seen the power of decentralized impact with the hydrofracking decisions that were the incredible Slotchy family, Helen and David, figured out that each town had the power to say we're going to zone in our town for industrial development or not. But then you've got some bigger energy decisions that are made where, our power plant is being instructed by the PSC. It has to come up with a plan that's natural gas. It's not allowed to come up with a plan that's alternative energy, renewable energy. So it takes a while to get to that point. And so if you have pointers for us on how you figure out where the best place is to influence the decision making that we have to deal with.
Well, I would, in a sense, my response to that, I did refer to a little paper I wrote on that one on energy federalism, and I'm going to answer very indirectly, in some sense, throw it back at people who understand the political system like you better than I do. At different levels, and Barb and others, about where in policy, where is it most likely to move? Because I'm an outsider to that, except at the very local level. What I want to draw attention to is our system of government, what federalism really means. I'm talking about government now, as opposed to sort of other forms of governance, which are also very important. But there is no permanent right answer to how centralized or decentralized we should be. be. I mean, I think there's a valid, vital conversation about local, state, and national policy that, you know, that too often gets reified about which side of the political spectrum you're on. I think one of the very interesting things about the fracking debate, for example, is traditionally home rule, localism was the bailiwick of the conservatives, you know. And now it's kind of, in this particular issue, it's being sort of appropriated for specific ends by the progressives and, you know, the anti-fracking movement. And there have been challenges, you know, think about what we want federal government to do. And I heard Mark, you know, talk about how, well, federal government is where, in my terminology, captured by big energy interests is most likely to happen. But think about, you know, the alternative, you know, there's stories and counter stories always, but think about the alternative at the local level. Do you really want to have a system where you're pitting the town of Newfield against Global Oil directly? You know, so again, I think you have to think hard and evaluate, and don't assume you have easy answers to these things with every specific contextual problem, because there isn't going to be an overall rule of thumb. And I don't know if other folks.
Miss Beth. Okay, last one. Beth. Quickly, please.
I've worked sort of with a lot of the rural climate skeptics that you were talking about in your presentation. And when I hear the presentations that David gave us yesterday and before, I've heard you, and I've heard you a couple times as well, so this is really new for me. The discussion of uncertainty, about how scientists are uncertain about what's going to happen, doesn't help. So,
We've been told that before.
You know, we need to get to these rural skeptics to change their attitudes so that we can work toward this problem. So what is your 1-minute elevator speech to convince these people of what they need to do?
Good question. Can always tell a good question when they pause.
We're certain about. So there's a lot of things that we're actually quite certain about. For example, a lot of, you know, the models go all over the place. Show me a model that shows it's going to get colder. You know, that's not going to happen. So you kind of start and build up from there. And I usually start with my audiences with the actual recent historical and, you know, the climate change we are right in the midst of now, before I even go to models, because people, you know, can believe the, you know, recent historical records. So I kind of start with people recognizing that some of what they're seeing around them isn't just anecdotal and their own observations, but some things that are happening across the whole northern hemisphere. And then kind of lead that into, you know, what we know. And I usually emphasize that the biggest uncertainty is what we as humans are going to do about mitigating, as Art did in his presentation. So that's kind of where I go with that. That's not an elevator speech, but that's my response.
I want to throw that around and actually go the other way with that. I think one of the reasons why I have to talk about uncertainty so much is because of the questions that I'm asked by the media in the audience. Was Hurricane Sandy due to climate change? Did it snow so much in Boston this year because of climate change? Was Hurricane Irene due to climate change? I mean, so when the questions are posed in that way by an audience, by the media, I don't have an answer. There isn't an answer. Yes, maybe, maybe not. There are some things. So kind of then goes back to what David said. You know, we only have to, you know, temperatures are going up. We see that. All records agree with that. I would say extreme rainfall or these heavy rainfall events is a pretty robust signal. But whether you mix that in with something like Sandy, which is a weather event, and you can look back in the historical record and find cases like that occurring, to ask that type of a question about an event, I think is unfair, but yet we're forced to answer those.
If I could just add one more thing, another phrase I often use is, you know, and I mentioned this, I think, yesterday at the thing in Cornell, but when I'm talking to farmers or whatever stakeholder groups or general audiences, we're really the first generation of humans, at least in modern civilization, who can't rely on historical weather records that tell us what to expect. Very unusual. I mean, we have to go back to the Younger Dryas period that, you know, 30, 40,000 years ago or 20,000 years ago to run into a human population was maybe dealing with something close to the level of variability we're going to see. So modern farming, you know, evolved when the climate became more stable about 10,000 years ago. And now we're going into a much possibly much less stable climate. So of all farmers ever, it's first generation that has to face that.
I think it goes back also to something that David said. I mean, we have to learn better how to handle uncertainty. My daughter had a track meet yesterday. I looked at the weather forecast, I made the weather forecast. It was a 90% chance of rain yesterday. I brought an umbrella. If it had been a 30% chance of rain, I might have said, nah, I'm not going to worry about it or something like that. So I dealt with that uncertainty in some way. I don't think, as a larger group, I think David alluded to that in his talk, we have to think about how best to deal with that uncertainty. I'm never going to be able to give you a straight answer.
Hey, just a comment on Art's weather predictions.
Really quick.
I was invited to a conference that was happening in Connecticut like 2 days before Hurricane Sandy, that it was going to be occurring on the date that Hurricane Sandy did. I asked Art, so what's with this storm coming in? Should I really worry about it? He said, Dave, don't go.
Don't go. So we're going to take a quick break. Just a quick word on that. Another scientist who I think has a very good answer to that, Kevin Trenberth, and I've used it a lot. When people say, was Sandy because of this? Was the drought last year because of this? He says there is no longer any weather event in which you can say that humans are not involved, that we have now changed the climate on this planet, and although we don't know, is it 20%, is it 90% human role, there is a human role in everything. And that's kind of, it gets you away from having to get into all the specifics and back and forth that frankly aren't very helpful and are not going to reach your average farmer or much less your average skeptic.